Hello, everyone. Welcome to the new episode of Professionals Unplugged. I am your host, Utkarsh Shukla, and today we have Dr. Kostas with us. So, Dr. Kostas, thank you so much for joining in.
Thanks very much for the invite.
So, before starting with the intro, let me just tell you a bit of background that what we are going to discuss today. Dr. Kostas is a data science lead as well as AI and ML expert. So, this conversation will be along the same topics. So, let's start with a very basic question. So, can you just introduce yourself to our audience, Dr. Kostas? Like, what do you think about yourself, or how you define?
I guess a good way to describe me would be like that I'm a professional in the data space, like in London the last 13, 14 years, with a background from software engineering, PhD in natural language processing, a broad, I guess, spectrum of experience in different industries, ranging from fintech to marketing tech, to retail, and so on and so forth. Right. And all these years are actually like working like in all these industries. I've seen like the landscape of like the machine learning data science seem to evolve like in extremely rapid ways, in like in unforeseen at some aspects ways, which is like a fascinating topic to be like. I really like this journey. So yeah, man, we'll actually get like into much more details, I guess, as we talk along. And thanks very much again for the interview.
Th- Thank you so much. So let's start from the basics, right? Nowadays, Gen AI is being trending all over the world. Everyone is running after it. Most of the companies they want to have AI as a tool or as a service being in their companies, right? What's your take on it, and how do you think is Gen AI different from the other aspects? Like we started with ML, then we go to the AI, right? And how do you like see the Gen AI right now?
Okay, so I have some strong opinions about that, right? Let's get started with the basic. Gen AI, or what like is generally called Gen AI, is a fascinating technology, right? I mean, we've seen some early, I guess, like it was like 5, 6 years ago, directions with transformers, like applied in natural language processing with BERT and so on and so forth. But then GPT 3.5 came along, and then it was, like the end of the world as we knew it, right? Like everything changes rapidly. To my mind, at least, there is no the distinction between machine learning and Gen AI. They're on the same topic, right? People call like, I mean, like the Gen AI kind of like term is, I guess, kind of like branding marketing term to differentiate and speed up things. And like we covered, like the basis of that. Now, in practice, Gen AI is, well, it's called Gen AI for now on, right? It's a fantastic technology. It's an amazing piece of engineering. Like, for example, imagine the technology, the hardware, the low latency, the failover that anything, for example, OpenAI needs to have to actually serve in real time or near real time all these like users that are actually using their service. So from technology perspective alone, this thing is amazing. Right. It's also going to like push a lot the boundaries of GPUs to make them like larger memories, much more reliable, and so on and so forth. So amazing piece of technology. Now, the thing here is at the same level, like before Gen AI, people used to call AI machine learning and everything, actually. And there was like a funny moment some years ago in a conference. Someone was trying to actually approach me to sell me, like time series forecasting like methods, and they were actually branding it as AI. It's like, yeah, guys, okay, cool. Yeah, like amazing piece of technology, but please don't call it AI, right? Like call it advanced time series, call it like advanced methodologies for optimization and so on and so forth, but please don't call it AI. So we're kind of like in the same, sometimes in the same realm here, right? Um, you need to know exactly the ups and downs, like the pros and cons of the technology you're using, to actually apply it in your domain, whatever the domain is, right? And in certain domains, Gen AI thrives. Like when we're talking about like text generation with low risk when hallucinations happen and so on and so forth. It's actually like a game changer. Coding, like I see, like the world going crazy, like with bike coding, startups and so on and so forth, and all like this hype that all software engineers will be replaced by machines in like 4 or 5 years, and then AGI is coming 26 and so on and so forth. Yeah, okay, calm down a bit. I guess the technology is fantastic. The technology is actually an extreme enabler for software engineers that they know what they're doing, like for professional in general, but you need to know what you're doing, right? Because you need to understand when the machine hallucinates, right? How to prevent hallucinations, but detect hallucinations if possible, how to minimize hallucinations, and from there on, like the sky is the limit. But we're living in exciting times, but we need to be a little bit grounded. That's my take.
Correct. And someone who wants to start a career in AI, right? What will you suggest to them, like how they should start? Suppose someone is at the college level who is doing basic engineering, right? What advice you would like to give to them if they want to start their career in, or they want to be an AI engineer?
Let's distinguish a little bit like the machine learning engineer from the AI engineer, which is kind of like new rebranding. And before that, we have like prompt engineers and
Hmm.
so on and so forth, which is kind of like disappears as a job description these days. Um, to my mind, an AI engineer is essentially a full stack engineer, like a very strong, like full stack engineer, but with also very strong understanding of uh, at least the principles of machine learning, statistics, and data science, right? You need to understand initially, at the end of the day, that essentially whatever like the Gen AIs are producing is essentially prompt completion. You need to understand the basics of how this technology work, right? And there are amazing resources out there to pick up like and understand what exactly happens. To name ones like Andrei Skarpathy, his videos like on like from actually neural networks from zero to hero and all the LLM series are an invaluable source of information. You most probably spend like say a week because like the videos are like 3 4 hours hours long at some point, but in the end of this process you would know things. Andre is a fantastic engineer, fantastic scientist, and extremely good at essentially um, explaining complex aspects of technology in a very simple terms. Like he's super smart. Like I think personally, I think he's one of the smartest persons alive at this point, right? So that's one thing. If you're going to go, like, of course, we need to know Python. This is like the tool of choice and so on and so forth. The basics of like how machines are working, maybe with like strong containerization technology like Docker and so on, so probably help you a lot to organize your code, make your things like the things you're building as close to production already as possible, and so on and so forth. But there is also the other thing that you may want to go a little bit more low level on the machine learning stuff, such as linear algebra, like basic algorithm, machine learning algorithms like linear regression, logistic regression. And again, there are like tons of information and lectures from all top universities like Stanford, MIT. You can actually like watch entire lectures available in YouTube, and then you have like all the material that's been like from leaders in the space like Hugging Face. Fantastic piece of information for all transformer related models. And I think I've said like quite a few sources of like how people can actually start their journey, which is again, it's a fascinating journey. You can actually do like amazing things today, not even imaginable, like literally 3 years ago.
Correct. And there is also a new thing happening in the market where people are using the models provided by OpenAI or the Hugging Faces or the Metas, and using those APIs and in their work. And do you think like they can be called as an AI engineer, or it's like just an API engineers? That
Uh, yeah, I mean, like the job titles. it's been always like a weird like situation. You have like data scientists and machine learning engineers. Before machine learning engineers, and then like later we have like ML DevOps engineers. We have data scientists type A, which is like more business oriented, versus data scientists type B, was like more like engineering. And at the end of the day, again, like based on my experience, like different companies have different mentality and different culture of how to approach things, right? Like some companies don't really want to waste time like prototyping things and then rewriting them and moving to production. So they would emphasize mostly like a much more robust software engineering skill on like their teams. So it's more like close to a ML engineer, data science type B or ML ops, right? Other businesses kind of like are willing to experiment on like, okay, yeah, but we'll have like a data science team, we'll prototype, we'll just be a little bit more business oriented and so forth. And as long as we have like a good model that we want to push to production, it's okay for our backend engineers or like MLOps engineers to actually rewrite it and make it like much more efficient and so on and so forth. Uh, I've been working like in my career both as a data scientist and as a machine learning engineer. And because I'm coming from a software engineering background, there was no difference at the end of the day from my side. Like could easily adapt and spend like enough time with stakeholders, but I was also like wear my engineering hat and also spend like time coding, debugging, mentoring team members, and so on and so forth. I mean, like I know people that are really hate to write production code, right? Like they will really like to actually prototype and so on and so forth. Others are like getting like really excited with the prospect. They're like, okay, my code is clean, like all works like all everything is working great, like login and so on and so forth. So they're most like prone to actually like work on the I guess like software engineering realm of things. But again, it's like business related and like from like a practitioner's point of view, preference related, I guess.
Correct. And you mentioned about using models. So many companies are nowadays preferring to use the models provided by, you can say, OpenAI or Meta and train on top of them rather than creating
Mhm.
own models from the scratch. So how do you see this picture and which method do you prefer? Or it depends on situation to situation?
It depends on various again like aspects. If you want to train like locally, right? You would need at least have the infrastructure, and some companies don't really want to actually make the investment, or they don't have like people to actually support the entire scale, or maybe like compute is expensive, right? Like because GPUs, I think like GPUs in the market, the crazy thing still going on, right? And in the last few months, speaking like for instance, so on and so forth, you can actually like allocate CPU for like 3 months down the line, but no one can actually secure like a fixed price for the GPU. So there is volatility on the availability and so on and so forth. So I can actually see benefit in both sides, right? The I guess the the pivot, like the, uh, the defining point for like moving one direction or the other is essentially data privacy. Some businesses are, and there are really good reasons for it, they're really protected for the data. They don't want to actually, like, and there was like, again, like discussion the last week or so, I guess, with some legal processes in the United States with FNA. So they've been actually forced to maintain the logs forever or something like that, like constant exchange. There is a thing, right? So whenever you're essentially uploading something, you need to know 100% if you're in certain industries that your data won't be actually stored and so on and so forth. So in that case, you would need to actually move compute locally, right?
Right.
And there are actually like models like around that. I think Mistral is doing that. They have like they're working like with certain other like businesses, and they install like hardware on premises like the models on premise hardware, so you don't really essentially have like any risk of like data leakage or like sensitive data and so on and so forth. And again, it's more like a question of how many engineers you have and how many engineers you will have like in the future to actually maintain and your system and keep them running and so on and so forth. Both strategies are good.
Yeah, I think that's a fair answer. And another question that I have in my mind regarding AI is the use case in the different industries. For example, if we talk about fintech, there is a lot of personal information that we have in our databases, right? Or you can say the fintech is all about personal information about people, right? So, what are the use cases that you think AI has in the fintech industry as compared to others one? Because in like retail industry or any other, it's easy to use the data that's public, right? But in fintech, it's come very private data, right? So take on.
So again, like on the context of private data and assuming like that you have like local models doing the stuff that you need to be doing, like a typical use case pretty much for all Gen AI models is essentially data documentation, right? Like and I guess you also work like in fintech environment, and you know that data quality is not as expected most of the times or enough times, right? And like previously, like in previous experience in fintech, there was a case like that. You have like a list of companies, and you want to actually find, say, for example, a company that's similar, uh, like similar companies to company, query company, right? And you have to deal with like potentially broken data, noisy data, data you're scrapping from collecting from the websites, data from Wikipedia, and so on and so forth, right? And extremely good use case for LLMs to essentially augment the data and transform them like into a reliable, machine readable format, like JSON, for example, right? Or you want to summarize, like quickly summarize entire PDFs of like company information. You want to extract information of PDFs. So it's essentially a combination of large language models and VLMs, like video language, like document image multimodal models, and so on and so forth. You want to do OCR, right? I think Mistral claims that they have like the best OCR LLM out there, right? And again, from fintech experience, depending like the major bottleneck was to essentially have like essentially an open set of potential formats, right? If you have like one format, you can actually like fine tune like a YOLO model or like something like that, and it will be working like reliably well. If your client has not like a fixed template of like documents, you're like a set of templates, and pretty much everyone can do anything. This is exactly the problem we're essentially facing with PDFs. Then you're out in the wild. Now with LLMs, it's much better, but you still have the hallucination thing going on, and especially if it makes a lot because you're like a single digit missing from like a field can have like major can make like a major impact. So you need both augment like your pipelines, data documentation, decision making tools, both with LLMs and traditional, let's call them like machine learning techniques with like convolutional neural networks, maybe transformers, like visual visual only computer vision models in conjunction with natural language processing, optimization, and so on and so forth. Right. So again, and if you think that the major label, like the major bottleneck for pretty much all machine learning things in the world was essentially data labeling, now you have okay, like of course, like again, like with a certain risk of like mislabeling, you have an extremely efficient way to label unstructured data, which is fantastic.
Mhm. Correct. And what are the customer use cases that you see,
For LLMs and Gen AI in general,
like customer
uh,
facing?
not fintech, right?
Not can we?
Yeah, I mean, but sky is the limit, all right? Like there is a massive industry movement now on tools that can actually like agentic frameworks and tools for code generation. And we see like about all of what's happening. Technology is fantastic. It's not mature yet. There are like stories of like hundreds or even thousands of websites getting hacked because the guys were actually getting them up. They don't really know the basics of security. So yeah, it's one thing to actually set up a POC, and it's a different thing to actually productionize it, right? But still, like, it's fantastic. Or you can have like LLMs on like as help desks, right? Like as people are working on various I guess various tasks on all this helpline industry and so on and so forth, like extract information, summarize information and so on and so forth. Essentially, uh, compacting, like making it much more efficient the process, right? And relying less and less on like human input and so on, and so forth, which I'm not sure that's a good thing, right? And from there on, there are like you can use LLMs for retrieval. You can use LLMs like for augmented retrieval with RAG and so on and so forth. You can actually do like Q&A Q&A applications on any actually industry like medical news and so on and so forth, right? So like literally, the sky's the limit. If you have like a problem that comes in raw data, you can actually plug in an LLM to like from small things like to maybe correct something, summarize something, to actually produce like a structured output of your content, which is like fascinating. So I don't think there's an industry not affected by LLMs still.
Correct. And talking about your journey till now, what were the biggest challenges that you have faced as an engineer?
Um, with Gen AI or in general?
Anything that you can share. What according to you were the greatest?
There are two kinds of challenges. The first challenge is like essentially, especially when you're working like with small teams, maybe like in a restricted budget and so on and so forth, that you need to make the best with not a lot of resources. So you need to be creative, right? You need to potentially go like a little bit more low level. You need, like, for example, I'll give you a concrete example on that. Previous job were essentially setting up like a classifier that was essentially had a target vector of 1,000 different labels, right? And the first, like straightforward way to approach is essentially fine-tune BERT. We have our data, we have like 1,000 target labels, fine-tune like the more like a BERT model. It was working extremely well. Inference time, test time, something like 10 texts per second, right? Good, but yeah, okay, maybe like in the scale we wanted, definitely not good. So spending a couple of days essentially fine tuning and essentially grid searching fast text, which is like in your next generation word vec. So we managed to actually get like similar models in terms of like accuracy, right? Like with the transformer based. Whereas the fast text model was essentially able to serve 1,000 texts per second in inference time, right? So the choice is obvious. What I'm trying to say here is that sometimes going directly into like state of the art is not necessarily the best approach for various reasons, right? You need to take into account compute, you need to take into account the inference speed, you need to take into account like data quality and so on and so forth. And maybe similar models are good enough to actually do what you're really after, right? Like in a very, very efficient way. That's the first part. Like the second part is essentially explaining or preventing people doing like stupid, sorry about that, mistakes, or when they're essentially considering like AI, not necessarily machine learning, like AI, like non-technical people or even technical people sometimes, as like a magic kind of tool, magic hammer that will solve all of their problems. And I've seen people in my career putting too much trust on things they shouldn't have, right? Like, or they're kind of like baiting, hedging at some point, I guess, I don't know. Which is a very interesting thing, trying to actually um, convince people like they have like their own mindset about how these things should work and so on and so forth, which is sometimes disconnected from reality. And as a data scientist and as a machine learning engineer, especially in leader roles, it's your responsibility to be able to explain complicated potentially concepts, like complex concepts, with non-technical terms. So people will actually understand at the end of the day what's the risk, what's the benefit of like moving, not necessarily LLMs here, like pretty much every technology. For example, I find quite surprising that people still don't understand, at least in scale, that LLMs are not deterministic machines, especially like the big players like OpenAI, Gemini, Claude, and so on and so forth, like Anthropic, and so on and so forth. So you will send the same prompt 10 times, you will get most probably 10 different responses, right? And people are, oh, okay, but how's that possible? And it's even, it's not because like they don't want to, right? Which like there is a certain aspect of that, which, but you can actually control it, could potentially control it. It's not feasible, right? Because I mean, OpenAI actually is doing it, I guess, in combinations of models and fingerprint, of the model, but it's not guaranteed because you have entire, data centers of and moving parts, right? Like you might have like a model deploying a model all continuously training and so on and so forth, and you cannot guarantee always like fixed responses given a seed, and that's weird, right? And whenever people come to me and say, yeah, but we need to definitely to make it like deterministic, like the only way to do it is that you need to host your models locally, right? And seed your models with like fixed seed and then control the seeds and so on and so forth, like in the generation and so on, right? And I find that very interesting because people essentially are, um, excited about the technology without understanding the implications of not being able to control a machine like a computer to respond back to you in a consistent manner, right? That's fun. That's fun.
Right.
Yeah.
And what are the advices that you follow in your life and you like to share with the people watching it?
As in what aspect?
As in terms of engineering, you can say, or how you live your life. Both we can combine, professional.
uh, we're living in fascinating times, right? And I think it's like a turning point in the evolution of the human race in various aspects. And I'm not one of the guys who actually believe that AGI will come soon. It will eventually come, maybe much sooner than we expect, but maybe not in the next couple of years or so. I won't bet, right? Like I've seen crazy things happening, so okay. But still, LLMs can't really actually like do basic arithmetic most of the time. So let's be a little bit more pragmatic with AGI and SI. What I would say is like maybe take a step back and try to look at the bigger picture, right? How all this technology essentially affect all different aspects of human life, like from education, from communication, from like day-to-day stuff. And I'll just give you like a very, very weird example. We actually made it to, I think, New York Times, like where a Greek lady was essentially speaking with ChatGPT and actually asking ChatGPT to read coffee, like, and give like, directions and stuff like if she want to divorce with her husband and so on and so forth. Like people are using technology in ways we cannot foresee as engineers, researchers, practitioners, and so on and so forth. And every time in this scale, with this, I guess, power in our hands, we need to be very, very conscious, both like in the good side and bad side of things, of what kind of like power we are listening to the world. Right? You can actually set up AIs to actually augment learning paths for pretty much like all people are willing to learn something, like from like children to people like in like high school unis, professionals and so on and so forth, just augment their experience. At the same time, there are already, like kind of like mixed signal studies that we're relying more, less and less on like traditional ways of essentially learning, and we have no idea yet on how this, like the next generation of students, will be affected by the use, like massive use of LLMs, right? And that's one thing. The other thing is, like, for example, it's an amazing thing to actually use any kind of AI on your scientific research, but there are like tons of examples in Scholar where people actually forgetting like a feedback message from ChatGPT and so on and so forth, like, and they're leaking that into their papers, right? So we need to. We're living in exciting times, and we need to make sure that we take all, like the responsibility required to actually make. I use a cliche here, which I kind of like hate it, but we have the power to make this world a better place, and we need to actually each one of us take like it's little bit tiny amount of responsibility, and yeah, collectively it will work, I guess.
I think that's the best point to end this podcast. So thank you so much, Kostas, for sharing your journey and insight with us. It was amazing.
Thanks very much for the invitation and really nice questions. It's always like to get like challenges and support. Thanks very much.
Thank you.